But on top of figuring out what they are, we also have to figure out their signs, and we use that we use Descartes' rule of signs to figure that out. And what you do is you look at the changing signs between each thing in the polynomial. So you could have a positive, a negative, an imaginary, or a zero root, and you look at the change in the signs. So there is only one change in the sign here, and that's between these two. So there can be one positive, two negatives, zero i's, and one zero, because the amount of the number has to equal to four, because four is the highest power in that polynomial. And so we also have to flip it, and we have to flip some of the signs. We only flip the signs for things in the polynomial that have an odd number as their exponent. So it's x to the fourth. Now it's minus 3x to the third, minus 4x squared. Now it's plus 12x, because it doesn't have a power, then it's just 1. And there's no constant, so it's just nothing. And 0 doesn't have a sign, so it's just plus. We do plus because I guess it's convenient, but plus 0. So now there's two changes in the signs. Here and here. But we already have it so that we already have an answer here where there's two negatives, so we already have that one. However, just because of the rules with the imaginary numbers, there can also be two imaginaries. So there could also be a possible combination could be 1 positive, 0 negative, 2 imaginary, and 1 0. We know this is 0 because there's no constant, and there can only be even numbers of I or 0i, because i's always come in their pairs, so there can never be an odd number of them. So those are the only possible combinations. These are the only possible combinations for roots for this polynomial.